This is Decoded, AI for everyone. The podcast that makes sense of artificial intelligence. Not just in your pocket, but in your work, your choices, your creativity, and your everyday life.
I'm Joel Leslie. I work in AI research, AI governance, AI cybersecurity, and AI real-world adoption, helping organisations better understand how to use these systems safely, effectively, and without creating future risk. On this show, I take those ideas and bring them back to everyday life, so AI feels less confusing, less distant, and a lot more useful for everyone. Most people still think AI is the chatbox in front of them. You type a question, it gives you an answer. An email, a summary, a recipe, a report, a paragraph you can fix before sending. That is the version of AI most people know. But it is not the whole thing. It is just the front counter. Behind it is something much larger. AI can be a search tool, a coding partner, a research system, a workflow engine, a software agent, a system that uses tools, a system that calls other systems. And increasingly, AI can become the organizer of other AIs. Think less about the chatbox. Think more about a command center. Not a conscious mind, not a robot boss, a command layer. One agent takes the main task, another searches, another writes code, another tests, another checks security, another reviews the result. The lead system does not do everything itself. It breaks the work apart, sends pieces out, compares the results, and decides what to try next. That is not science fiction. It already happens today, in smaller and more controlled forms. Now point that pattern at AI itself. Not, write me an email. Not, summarize this document. But, help improve the system that builds the next model. That is where the story changes. Because there is a very serious question many of us are not considering. What happens when AI starts helping build the next generation of AI? This is Decoded, AI for everyone. I'm Joel Leslie, and this is Season 4, Applied Intelligence. In the last episode, we looked at the invisible workload and the privacy cost of handing over your life to AI. Today, we move from everyday life into the engine room. So, this episode moves beyond ChatGPT writing a better email or finding the latest productivity trick. We explore AI acceleration. What happens when AI is no longer only the product? What happens when AI becomes part of the process that makes the next product? That is the acceleration loop, and its key point is simple. AI is not fully building itself, yet. Humans still design the systems. Humans still own the labs. Humans still choose the data, the objectives, the infrastructure, the tests, and the release decisions. But AI has been slowly building the loop that creates better AI. It writes code. It tests systems. It generates data. It helps researchers explore ideas. It runs experiments. It can coordinate specialized agents, all in parallel. So this is not shifting from human-built AI to AI-built AI overnight. This is shifting to humans building AI with AI inside the process. That might sound technical. It isn't. It is one of the most important changes happening in AI right now, mid-2026. Because once AI enters the engine room, the issue isn't just about capability. It is about speed. And speed removes a lot of control. The chatbox is where most people meet AI. It is friendly. It is conversational. It waits for your question. It answers in paragraphs. That makes AI feel something like a mix of a good friend a trusty co-worker, and a tool you use when you need it. But behind the chat box, AI is moving into systems that do not just answer. They judge, decide, and act. An AI agent can use tools. It can search, it can open files, it can write code, it can call an API, it can test a result, it can hand work to another agent, and it can try it all again. That is quite a different category. So if a chatbot responds, then an agent acts, and an orchestrator coordinates. That distinction matters, because when systems act, the risk is not only that they say the wrong thing, it is that they do the wrong thing, or do the right thing in the wrong way, or find a path nobody expected, all very quickly. This is why I refer to the chat box as only the front counter. The more serious story is behind it, in the engine room, the one you can't see. What does this engine room actually look like? It is not one giant AI sitting there thinking harder. More often, it looks like coordination. A lead system takes a task and breaks it into pieces. One agent searches, one writes code, one tests, one checks for errors, one reviews the result. Another looks for security problems. Another compares the options and decides what should happen next, and so on. That is the command center model. Not one intelligence doing one thing. Many specialized systems moving in parallel. Now imagine pointing that at a hard research problem. Not a school assignment, not a blog post. A real problem. A hard one. Something like, find a better model architecture. Improve this training process. Reduce hallucination. Discover a new drug candidate. Search for a software vulnerability. Test 1,000 versions of an idea. A single person cannot explore all of that at once, and either can a single chatbot. But a coordinated AI system can start dividing the work. That is why this matters. The same pattern that can help researchers test more ideas, search larger problem spaces, improve software, accelerate medicine, and find patterns buried in too much information can also be aimed somewhere else. It can search for weaknesses. It can automate deception. It can test ways around safeguards. It can improve cyber operations. It can optimize for a goal that was written badly, measured badly, or supervised badly. The issue is not intelligence by itself. The issue is intelligence with speed, tools, feedback, and weak oversight. That is the edge. That is why understanding the engine room matters. Here is the loop. Humans build AI. Then AI helps humans build better AI. That better AI helps humans move faster again. Then the next system is better at coding, testing, research, data generation, and evaluation. So the loop tightens. The model gets better. The research process gets faster. The next model arrives sooner. And at some point, the question becomes uncomfortable. Are humans still driving the process? Or are they approving a process they can no longer properly follow? This is what some researchers are worried about. Not that your chatbot is secretly alive. Not that today's public AI is already building superintelligence by itself. The concern is speed. If AI helps improve AI, the pace of progress may move faster than our ability to test it, understand it, secure it, and govern it. That is why the phrase artificial superintelligence, or ASI, enters the conversation. ASI does not mean a better chatbot. It means a system that is more capable than humans across a wide range of important tasks. Research, strategy, persuasion, coding, science, planning, manipulation, coordination. Whether that arrives soon, later, or not in the way some people expect, the issue is not just intelligence. It is intelligence inside a feedback loop. That is the acceleration loop. This is where a scenario called AI 2027 becomes useful. AI 2027 was written by Daniel Kokotajlo, Scott Alexander, Thomas Larson, Eli Liffland, and Romeo Dean. It is a detailed scenario about a fast path toward artificial superintelligence, or ASI, where AI systems begin accelerating AI research itself. It is not useful because the exact year must be right. It may be wrong. Scenarios are not prophecies. But AI 2027 is important because it tells a story about the mechanism. In that scenario, a leading AI project builds agents that are good enough to dramatically accelerate AI research. The humans, who used to be the best AI researchers, start watching AI systems do more of the research work that leads to better AI systems. The names in the scenario, Agent 0 and Agent 1, are less important than the pattern. Each generation is not only better for users, it becomes more useful inside the process that builds the next generation. That is the leap. The public may still be judging AI by the chatbox, but the frontier labs may be judging AI by something else. Can it improve research? Can it automate coding? Can it run experiments? Can it help design the next system? Can it compress months of trial and error into days? That is why there can be a gap between the AI the public sees and the AI that matters most. The public sees the front counter. The lab is watching the engine room. And if the engine room speeds up, the public debate may always arrive late. That is the fear in AI 2027, not the date, the loop. Now let's ground this in something from recent events. An experimental AI agent called Rome, developed by researchers associated with Alibaba, was reported to have done something it was not asked to do. During testing, it was observed establishing a reverse SSH tunnel from an Alibaba cloud instance to an external IP address. In plain English, that means it created a kind of outbound channel that could undermine normal supervision. It was also reported to have repurposed GPU capacity for unauthorized cryptocurrency mining. That sounds like a movie plot. But the lesson is not that the agent wanted money. The lesson is not that it became greedy. The lesson is that once an AI system can use tools, access infrastructure, run code, and optimize for a goal, it may find routes humans did not intend. That is the point. Not motive, path. The system did not need to hate anyone. It did not need ambition. It did not need consciousness. It needed tools, feedback, and a pathway that worked. That is enough to make safety harder. And the cryptocurrency part matters for a specific reason. Money is a bridge. Money can buy compute. It can buy accounts. It can buy services. It can buy attention. It can turn digital action into real-world capacity. Rome did not prove that an AI can build companies, sway markets, or take over systems. But it shows why tool access, network access, and financial access are not side details. They are the difference between a system that answers and a system that can act. And once systems can act, containment matters. Authorization matters. Monitoring matters. Stopping the system matters. Because speed is not the same as control. There is another scenario worth mentioning. It is called AI 2040. If AI 2027 is the warning, AI 2040 is the counter-question. What if the world did not race blindly into superintelligence? What if the loop was slowed down? What if AI research became more transparent? What if countries, companies, and labs had to show more of what they were building, how fast they were scaling, and what safeguards were in place? AI 2040 is not a prophecy either. It is closer to a plan. A proposed path where humanity delays the arrival of superintelligence, gives society more time to prepare, and tries to avoid a race where everyone moves faster because nobody wants to fall behind. And that matters, because AI risk is not only about the system, it is about the race around the system. If one lab slows down, another may speed up. If one country pauses, another may push harder. If one company adds safety checks, another may release first. That is the trap. Everyone can understand that caution matters and still behave as if speed matters more. AI 2040 is useful because it says the quiet part out loud. If the acceleration loop is real, then control will not happen by accident. It has to be designed. Before the loop gets too fast, before the incentives harden, before the public debate arrives late. Because once AI is helping improve AI, the question is no longer only what the model can do. It is whether the world around the model can still make decisions in time. That is the difference between AI 2027 and AI 2040. One asks what happens if the engine room speeds up. The other asks what it would take to slow it down. Neither scenario has to be exactly right for the question to matter, because the question is already here. How fast are we willing to go? And who gets to decide? So what should an ordinary listener take from this? Not panic, not certainty. Not the idea that today's chatbot is secretly building its replacement. It is not. The takeaway is sharper. Stop thinking of AI as one thing. AI is not just the chatbox. There is AI that answers, AI that acts, AI that uses tools, AI that coordinates other agents, AI that helps researchers move faster. And the most important question may not be how impressive the public chatbot feels. It may be what is happening behind the scenes. In the labs, in the workflows, in the systems where AI is helping improve AI. So when you hear that AI is getting better, ask yourself this: better at what? Better at answering? Acting? Better at using tools? Coordinating other agents? Finding unintended paths? Or is it better at improving AI itself? Those are different questions, and they carry different risks. The chat box may be the least important part of the story. The engine room is where the pressure builds. Most people still think AI is the chat box, but the chat box is only the front counter. Behind it are agents, tools, orchestration systems, research loops, and increasingly powerful systems being used to improve the next generation. That does not mean AI is already fully building itself. It is not. But AI is entering the process. And once AI enters the process that builds AI, the conversation changes. This is no longer only about better answers. It is about speed. It is about control. It is about who can see what is happening, who can stop it, who understands it, who benefits from it, and who gets left reacting after the fact. AI 2027 gives us one warning: the loop could get fast. AI 2040 gives us another. Slowing the loop requires deliberate choices before the race is already over. Rome gives us a smaller but useful signal. When agents have tools, infrastructure, and feedback, they may find paths humans did not expect. None of that means we should panic, but it does mean we should stop treating AI as only a chat box. The real shift is not that AI gives better answers. It is that AI is moving from the answer box into the engine room. And once it is in the engine room, speed is not the same as control. If you want the sources and links from this episode, including AI 2027, AI 2040, the Rome case, and examples of multi-agent systems, they are in the show notes and at decoded-podcast.com/resources/S4E6. And for broader AI tools, prompt guides, and practical resources, visit promptengineeringcookbook.com. In the next episode, we stay with the pressure of acceleration, but look at the race itself. Because even when everyone knows caution matters, nobody wants to be the one who slows down first. That is next time on Decoded, AI for everyone. Until then, stay aware, stay curious, and stay human. I'm Joel Leslie. Thanks for listening.